What we're doing in this section now is the Year 8 motion and pressure knowledge test. Lots of words, bit of maths in it, right? So what you've got to do is you've got to absolutely concentrate and understand. What is the formula for calculating speed? Speed equals distance divided by time. Okay, incredibly common, whatever year group you're in, that equation is going to come up. Speed is in meters per second, distance in meters, time in seconds. Right, so if they ever say time in minutes, you convert it to seconds. If they say distance in meters, convert it in kilometers rather, convert it to meters. Now, I love these graphs. All right, so what I'm going to do is I'm going to do each individual one. We're going to go A, going to go B, going to go C, and I'm going to go D, which really hasn't given me very much space over on the side here, right? So that was a bit daft, right? Now, these graphs, what you've got to do is you've got to look at the time. So this axis here is time, okay? So look at it and just picture exactly what's going on, 9 till 10, 10 till 11. Then the most important thing about any of these graphs here is you look at this. That says it is distance. All right, so now what I'm going to do now is I'm going to start at 0 and I'm going to follow A and I'm going to go to start at B. So A is travelling from 9 o'clock till 11 o'clock. Okay, so it's travelling at 2 hours. But the most important thing about this now is talking about what its motion is, which is what it's all about. So if it starts at 0 kilometres from the start and ends at 30 kilometres from the start, what it's gone is it's gone from 0 to 30 kilometres away. And because it's a straight line, it is gone at a constant velocity. Okay? Now, with velocity, you could also write down speed. Okay, now there is a difference between them that then you'll do in kind of year 11 forces. B, right now, this is dead important. So if you get to B now, right, what you've got is you are 30 kilometres from where you started. And after an hour, you are now still 30 kilometres away. So therefore, what's your motion? Stationary. C. So now from C, what colour shall I do? Let's do dark blue. From C to the end of C, you have travelled, you've gone from 30 to 60 kilometres, but you've only done it in half an hour. So C, you are at a constant speed, but what you can do is you are travelling at a faster constant speed than A. So I'm going to put here faster than A. Now obviously you can write this neater on your test. D. D then makes it interesting in the fact that you start there 60 kilometres away, and what you do is then you end at 0. Alright, so there's a couple of facts about that. Again, because it's a straight line, you can say you're going at a constant speed, but you're back at home. Because now you're a different distance away. You were 60 kilometres away, now you're 0 kilometres away, which means you've gone back to the start. Now, thinking about that graph again, right? What does the gradient of the line tell you on a distance time graph? It is your speed. And you use that by doing distance travelled over time. What does the gradient of the line tell you on a speed time graph? Okay, now that's going to be a little bit confusing because we haven't actually talked about it yet. Acceleration, right? And I'll come back to that in a minute, but that's kind of the answer to that section. Right. Now, whoever's done this graph, I don't know why whoever's done this, they put the same PowerPoint slide on, right? So that's just a bit silly, right? So all I'm going to do is I'm just going to repeat what I did before. I'm going to go A, B, I'm probably going to do this a bit better because I've learnt now, C, and then I've got D. Okay, then what I'm going to do is I'm going to look at the time, so from 9 o'clock till 11 o'clock, it's a straight line, so therefore it must be going at constant speed. But if I now look at this axis here, this axis now tells me it's the speed that it's going. So from here to here, it's going from 0 meters per second It's up to 30 meters per second. So what it's doing there, it is accelerating. It's getting faster from 0 to 30. Then I look at B. Right, look at B. Before it was stationary, but now if I use my lovely straight ruler and I go all the way across, it's travelling at 30 meters per second. So therefore, it is going at a constant speed. It's travelling at 30 meters per second. C, there to there, it is also accelerating, right? Faster than A, because it's steeper. And then D is then decelerating, right? And it's going from 60 meters per second to 0. But it also doesn't tell you where it ends up. All it does is it tells you it's decelerating, and eventually it then becomes stationary. Question number 6, what is the pressure formula? Pressure equals force divided by area. Pressure measured in pascals, force in newtons, area in meters squared. Right, question number 7. Describe a method you would use to calculate the pressure you apply when stood on the ground. Right, so thinking about it now, right, I'm sat on a chair, right, if I stood up, the pressure I'd be putting on the ground. Now, the method you would actually do to do this uses 2 formulas. The first one is force equals mass times gravitational field strength. Because what you've got to do is you've got to then, using the formula that we had before, you don't know the pressure and you don't know the force. So to work out the force, you need to use this formula, formula number 1. Force equals mass times gravitational field strength. You can use that using a mass balance, and that is 10 newtons per kilogram. That's the gravitational field strength on Earth. When you've worked out the force, what you can then do is then you do number 2, which is you've got to then work out the area. You've got to work out the area of your foot, and you need it in meters squared. Okay, so that's then your mathematical part of it. Part number 3 is then you use pressure equals force divided by area. All right, you've got your force from there, which is your mass times gravitational field strength, your area from here in meters squared, divide them, and that'll then give you your force, the pressure rather. Question number 8. Complete the diagrams. Each bottle is full of water. All right, so I'll do it in blue because blue's nice. A bit less, a little dribble. Right, because what you got is there's much higher water pressure at the bottom here to squirt that water out. And this one, if I can draw it, they should be exactly the same. Question number 9. Explain why a can collapses when you move air from it. Right, so I'll draw a can. Oh, I'm making silly noises now, I'm losing the plot. Right, so what you've got inside there is you've got particles hitting the side of the can. Okay, this is a normal can. From the outside, you've got particles hitting the outside. Right, and what that is then when it is equal. All right, so that is kind of like stage 1. Then, if you take all the air out of it, what I've then got is I've got no air inside, but I've still got force or pressure on the outside. And that pressure on the outside, number 2, makes it collapse. Now that question there is a little bit difficult. I like doing it in pictures, but what you're going to have to do is when you're actually doing this as a test, you're going to have to do it as words. Add the pictures in as well if it helps, right? But then you need to explain rather than using a diagram like I've done. Okay, you can convert it into words. Question number 10. Moment is the turning force of, the turning effect of a force about a pivot. Okay, so that's your definition. It's the turning effect of a force about a pivot. How would you balance this using a 2 Newton weight? Right, so the equation that we're using in this is a moment which is what we just talked about, equals force times distance. Okay, so force is newtons, distance is in meters. Okay, so a moment is Newton meters, which is newtons times meters. So 5 newtons there, 20 centimeters. I've got a 2 Newton mass. So the moment on this side is 5 times, well, I could do it in centimeters for now. 5 times 20 is 100. Okay, normally what you do if it's a calculation is convert that into meters, which I could have done, right, which is 0.2. And on this side, I've then got 2 newtons equals 100, right? So what number, right, am I then going to multiply the 2 by to get up to 100? That would be 50. So I would then put my mass there, which is 50 centimeters, and it would be a 2 Newton mass there. Question number 12, what is the centre of mass? Where is the centre of mass on the shapes below? Okay, it is where the mass of an object is concentrated. Alright, so middle, line through, line through, line through, so wherever all those lines mean, that is in the centre of the mass. This one is probably easier to do, just join those points there. Whoops, not supposed to be curly like that, that's a shocker, that's a shocker. But wherever they meet, that is then the centre of mass. Keywords, the amount at which speed increases in 1 second is the acceleration. The mass of material of a certain volume, right? Density, because we've got mass and we've got volume in there. The force exerted by air particles when they collide with a surface, gas pressure, the unit of speed, meters per second, the units of pressure, pascals. Right, some good understanding, right? Some good understanding, right, going in on that topic, and there's also maths. Right, so have a look at the maths, have a look at the maths questions, right, and you need to learn the equation and learn the units. Once you've done this as there, you need to go and go to the blank test. When you found the blank test, write it down on a piece of paper and keep testing yourself over and over and over again.